All right, class, this is section 2, chapter 13. Okay, what we're covering today is simple machines. Okay, in the simple machines category, we have the lever family and we have inclined plane family. And in each of those, we have 3. So in the lever family, we have just the simple lever, the pulley, and the wheel and axle. Okay, and in the inclined plane family, we have the simple inclined plane, which is like a ramp, a wedge, or the screw. Okay, the lever family, how it works is it has a fulcrum. Okay, the fulcrum is the pivot point. Okay, they don't all work like this, but this is basically, it'd be like a teeter-totter, or, if you're using a crowbar or something like that, that would be a lever. You have your input force on one end, usually further away from the fulcrum, not always, but usually, and then the output force on the other side. Okay, a pulley, the center of the pulley is the fulcrum. Okay, if you only have one pulley, the input force and the output force are almost the same. Okay, each time you add a pulley, your input force goes down, it decreases, while your output force will remain the same. You do have to move this further. Okay, we talked about that in last section. You will have to move this further, but your input force will decrease. It makes it easier. Okay, and then your wheel and axle. Again, the center is your fulcrum. Imagine this is a lever where you're turning the wheel, and around the outside is where your input force is. Your output force is just on the inside of that wheel, whatever shaft it's connected to. Okay, notice how much longer our output force arrow is compared to our input force. Okay, I've tried to draw those lines comparable. Your input force is going to be about the same, maybe slightly less. In this case, input force is quite a bit less here than the output force. Okay, now inclined plane. You have a ramp. Your input force, you're pushing up. Again, this would be the output distance. This would be your input distance, what you actually traveled. Okay, compared to your output distance. Your wedge input force would be the top wherever you're hitting the wedge down. Your output force is actually on both sides. And then a screw is basically just an inclined plane just wrapped around a cylinder or something round, right? Okay. And then the last thing, as far as your lever goes, you have 3 classes of levers. You have a first class where the fulcrum is between your input and output. Now, how much your input compares to your output depends on where you put your fulcrum. Okay, and now that's for another lesson. But as far as the first class lever, the fulcrum's in the center. Second class lever, the fulcrum is on one of the ends. Your output is in the middle. Your input is on the end. An example of your first class would be like a teeter-totter. Okay, an example of a second class lever would be like a wheelbarrow. Okay, where you lift on one end and the load is in the middle, what you're actually trying to lift. Okay, a third class lever is where the input is in the middle. Okay, your fulcrum's on one of the ends, your output is on the other end. Okay, this would be like a shovel, fishing pole, things like that. Okay, where if you've got a fishing pole, right, your pivot point would be on one of the ends. Where you're actually pulling is in the center. Your output force is on the end. Okay, same thing as with a shovel. Your pivot point would be here. What you're actually using to move the load on the end is in the middle, and then your output is on the end. That's simple machines.